we are to find the volume of the solid that is generated by rotating the region bounded by y equals 8x cubed, y equals 0, x equals 1, about x equals 2. So we have the region that is bounded by these curves. It's this region here. And we're going to rotate it about the line x equals 2. And when we do that, the shape we would find would be something like this. And if we were to draw a representative section here, and we're going to use the washer method, so I'll draw lines that are perpendicular to the axis of rotation, and then see what this thing looks like here. It would make a washer that looks like this, and then put some thickness to it. And that thickness is in the up and down direction, so it will be a change in y, or a delta y. So our variable of integration now, when we go to find this volume, is going to be y. So let's go ahead and draw what this washer would look like if we could look down on the top of it. And it would look something like this. And the radius now would be, the outer radius would go out to this curve here. So, going out to the edge, the outer radius, if this is some x coordinate, x sub I, well, the length of that would be 2 minus x sub I. So the outer radius would be 2 minus x sub I. The inner radius is just going to be then the distance from the line x equals 2 to the line x equals 1, which is the edge then of this shape. So that's just 1 unit. So our inner will be 1. Okay, then the thickness of this washer would be delta y. So what we would need to do is find the area of that face and then multiply it by the thickness to get a representative volume. So A sub I then, any area of any disk that we would, or any washer that we would generate here, would be pi r squared. So that's now an outer minus an inner, so we're going to go pi times the outer radius, 2 minus x sub I squared, minus the inner radius, 1 squared. Okay, but we don't want x, we want y. So what we're going to need to do is solve for x in the equation y equals 8x cubed. So if we do that, 8x cubed equals y, divide both sides by 8, and we would have x cubed equals, and we'll just maybe call it 1/8 y, and then cubed root both sides, and we would wind up with x equals 1/2 y to the 1/3. So our area then would be a sub I equals pi times 2 minus 1/2 y sub I to the 1/3 squared minus 1 squared. And the volume then of any one of these washers would be pi times, and we might just go ahead and multiply this out. We'd have 4 minus 2 y sub I to the 1/3 plus 1/4 y sub I to the 2/3 minus 1 times delta y. And then that can be simplified a little bit. V sub I would be pi times 3 minus 2 y sub I to the 1/3 plus 1/4 y sub I to the 2/3 delta y. Okay, so now an estimate of the entire volume would be the sum I equals 1 to n pi times 3 minus 2 y sub I to the 1/3 plus 1/4 y sub I to the 2/3 delta y. And the actual volume we could get then by finding the limit as n goes to infinity. Sum I equals 1 to n pi 3 minus 2 y sub I to the 1/3 plus 1/4 y sub I to the 2/3 delta y. Then, in order for us to find the actual volume using a integral, we would need to have our limits of integration. So we need to know then where does y start and where does it end? Well, it starts down here at 0 and ends up here where the line x equals 1 crosses the graph y equals 8x cubed, which is going to be at 8. So our limits of integration then will be 0 to 8, and then our function will be pi times 3 minus 2y to the 1/3 plus 1/4 y to the 2/3 dy. Okay, then integrating this, we would have pi times 3y minus 3/2 y to the 4/3 plus 3/20 y to the 5/3 evaluated from 0 to 8. And then plugging those values in, we should wind up with pi times 24 minus 24 plus 96 over 20 and then minus 0. And 96 over 20 would reduce to 24/5, and then that would be multiplied by pi. So that would be the volume of that solid.